All right, so in this example, we are looking at a rhombus. Now, what we're looking with and we're focusing on explicitly are the angles in a rhombus. Now, in our previous video, we looked at some of the properties of a rhombus. Now we're going to be applying those properties, namely, like I said, with the angles and the diagonals as well. The first angle we look at is I have given you that this portion of angle B, angle ABK, is 41 degrees. We can actually use this to find all of the angles inside of our rhombus. I'm going to actually keep going through and go through. I think it's easier to find all of the big interior angles first. For example, given this portion of the angle, it's very easy to figure what angle B is going to be. Angle B is going to be, does anyone know what angle B is going to be? Go ahead, yes?
Angle B will be 98.
It's going to be 82. 82 degrees, because this other portion also has to be 41, right? We know that a diagonal bisects this angle, so both of these portions need to be the same. Does anyone think they can tell me what angle C is going to be? Angle C. Yes, Malik?
98.
Now we got 98. And how did you get that 98?
49 plus 49.
Well, that is true. That's one way of looking at it. What's the way we can figure out this whole angle, though? Go ahead. Excellent. We know that angle B plus angle C needs to add up to 180. And if we know angle B is 82 plus angle C equals 180, we just need to subtract 82 from both sides, giving us that C equals 98 degrees. Excellent. Thank you. What about angle D? Who can tell me what the measure of angle D is going to be? Yes, go ahead.
82.
It's also going to be 82. We know that angles across from one another, or opposite of one another, are congruent. What about the measure of angle A? Go ahead.
That'll be 98.
That will be 98 as well. Really easy to find those big angles first. So I'm going to write those in. Angle A is 98 degrees. Angle B is 82 degrees. I'm going to write that a little better. 82 degrees. We know that angle C is also 98 degrees. And angle D is 82 degrees. Now, let's try and find some of these bisected angles on the inside. We found angle 1 was already 41 by the properties of a rhombus. How can we figure out the measure of angle 2 and 3? Yes, go ahead.
Divide 98 by 2.
You got it. Take that angle and divide it into 2 equal pieces.
49.
They're both going to be 49. And they should both be the same because these have to be congruent to one another. 49, 49. Now, one that can be a little bit more difficult would be finding the measure of angle 4. But we have a special property. We know that the diagonals bisect and form a perpendicular bisection. Yep. So we have angle 4 is going to be 90 degrees. Which other one's going to be 90 degrees? Angle 7 is also going to be 90 degrees. Very good, because we know all of these have to be 90. Very good. What about the measure of angle 5? Yes, go ahead.
Same as 2 and 3.
Not the same as 2 and 3. Not angle 5.
Angle 5?
Uh-huh.
That'll be 41.
It's also going to be 41 because it's 82 divided by 2. We're splitting this big angle, all of angle D, into 2 equal pieces. It's 41. It's easy to follow with number 6 as well. We know that all this angle is 98, so angle 6 is going to be equal to 98 divided by 2. We're splitting it in half, which is also going to be 49 degrees. So you'll see in this entire diagram, there's not that many different angle measures. Because we have the perpendicular angles here, because we have the bisection here, we know that both of these are going to be the same. They both have to be 41. We know that both of these have to be the same, 49. Those diagonals bisect one another. Therefore, it makes it a little bit easier for us to work with. All right, for our next problem, we're using the exact same rhombus, but now we're just given lengths instead. We know that AB is 5. We know that KC is 4. and all of BD is 6. I'm just going to use the highlighter tool to mark that. All this right here, this is going to be 6. BD is going to be 6. And what we need to find is very simple. We're going to find all of the sides, BC, DC, AD. We're going to find a length of the diagonals, or in portions of the diagonals. I want to know what AC equals. I also would like to know what KD equals and AK equals. These are going to be the lengths that we are concerned with for this problem. Now, the nice thing about a rhombus is, as well as being able to find many of the lengths inside of it, or the angles inside of it, the lengths come quite easy as well. In fact, the easiest portion is finding all the sides, because all the sides are congruent. We know that all of these sides have to be the same. So all of the sides have to be 5. That's part of that is the definition of a rhombus. All the sides are the same. We also know some great properties about the diagonals, beyond just the angles with the diagonals. We know, because a rhombus is a parallelogram, that the diagonals bisect each other. So BK is congruent to KD, and AK is congruent to KC. So you can use this to find those missing lengths. If I know that KC is 4, that means I know that AK also has to be 4. What makes it pretty easy to follow that AC, using the segment addition postulate, 4 is going to be 8. Now, KD, on the other hand, is just not much more difficult, but more difficult. Sorry, this is KD. It's kind of a little hard to read there. KD. If we know that BD is going to be 6, they're going to split each of these in equal pieces, so it's going to be 3 and 3. So KD is 3. So we can use not only the properties of a rhombus, we also use the properties of a parallelogram when finding lengths inside a rhombus. We're applying multiple properties here. We have to apply and realize that a rhombus is also a parallelogram, so we use those properties as well, like we looked at in our earlier examples. These are both examples of level 1 rhombus problems, where you're just given some information, you need to solve for some of the remaining pieces there. You need to break the pieces down, look for your properties, and then analyze, well, what pieces am I looking for? Am I looking for sides? Am I looking for diagonals? Am I looking for angles? Or am I looking for lengths? As soon as you break it down to that, each question becomes much, much easier. Now, once you've kind of gone through this video and you understand it, copy down the notes, check out my video on level 2 problems for a rhombus. These are problems that involve variables and variable expressions, solving for those lengths, and then substituting back in. But it can be very, very hard to work on those types of problems if you are having trouble with these level 1. So make sure you understand those level 1 questions before moving on. Make sure you check out my channel, like and subscribe. Check out our other videos on parallelograms, rhombuses, and rectangles. All right, thank you.